Hello, my dear students. Welcome to the first lecture in the course Operating System, that is OS. Myself, Rafiqul, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Basically, operating system is a theoretical subject, but as well as there are numericals also. So first we have to clear the concept of theory, and after that we have to solve some numericals to clear the theory. In this first lecture, I wish to explain the syllabus of operating system. So basically, in operating system syllabus, there are total course duration 32 hours, and credit point 3. And in this syllabus we have total 5 modules. So here we have total 5 modules. And in module 1, basically module 1 it is on overview. So under module 1 we have to study introduction, to operating system, that is OS. Number 2, system boot. You must heard the term booting. So here we have to study system boot. Next, we have to study goals and functionalities. Goals and functionalities or services of OS. Next, we have to study types of OS. Types of OS. After that, we have to study interrupts, traps, and signals. And next, we have to study, this is very important, hardware protection. Hardware protection. So in this hardware protection part, we are going to study dual mode operation, IO protection, memory protection, and CPU protection. Next topic under this module, that is operating system structure, OS structure. Here we have to study layered approach and microkernel structure. And at last, we have to study system call. So these are the topics which we have to cover in module 1. So you see in module 1, basically the basic concept of operating system. Now go to module 2. So in module 2, basically on process management. So module 2 basically on process management. Process management. And in this module, basically we have 3 parts. In this module, we have basically 3 parts. So first part is on process. Second part is on thread. And third part is on CPU scheduling. So there are 3 parts in module 2: process, thread, and CPU scheduling. So in this process part, we have to study process concept, process versus program, process state, diagram, process terminologies, etc. So this is all about process. So now in this thread part, we have to study thread and process. Actually, thread versus process. Number 2, which we have to study, this is called benefits of thread. Benefits of thread. Number 3, user level and kernel level thread. User and kernel level, user and kernel level thread. And at last, thread models. So under thread part, we have to study thread concept, process versus thread, benefits of threads, user and kernel level threads, and thread model. And in CPU scheduling part, this part is very much important, and here we have to solve different numerical problems. So here we have to study the different time related to a process, that is arrival time, waiting time, response time, turnaround time, burst time, etc. And after that, here we have to discuss about preemptive scheduling and non-preemptive scheduling. And then at last, we have to study different process scheduling algorithms like FCFS, SJF, SRTF, round robin, etc. So these are the topics which we have to study in module 2, and this module is very much important in your exam as well as in your different campus interview. Okay, so now next module, that is module 3. Module 3. Actually, module 3 also, it is a part of process management, and here basically we have two parts, that is process synchronization and the second part is deadlock. So in module 3 we have two parts. The first part is process synchronization and the second part is deadlock. And in process synchronization part, we have to study critical section problem. Critical section problem and how to solve a critical section problem. So here we have to study critical section problem and solution of critical section problem. So here we have different type of critical section problem and the solution technique, software based solution, hardware solution and operating system based solution. We have to study one by one in detail. And at last, in this part, there are some classical synchronization problem, that is producer consumer problem, reader writer problem and dining philosopher problem. And in deadlock part, here we have to study deadlock and its necessary conditions, resource allocation graph and methods for handling deadlock, that is deadlock prevention, deadlock avoidance, deadlock detection and at last recovery from deadlock. So these are the topics which we have to study in module 3. Okay, now go to module 4. In module 4, Actually, module 4 is on main memory management. Main memory management. So in main memory management, this module is also very important for your exam, semester exam, as well as your interview. In this module, we have to study logical and physical address space. Here we have to study logical versus physical address space. Number 2, we have to study various memory management schemes like single partition memory management, multi-partition memory management, paging, segmentation, virtual memory concept, page replacement algorithm like FIFO, LRU, optimal page replacement algorithm, and at last thrashing. So this module, basically we have to study the different memory management concept, how operating system identify or manages the computer memory. And last, that is module 5. Here we have to study about the secondary memory management. So in module 5, we have to study secondary memory management and input output management, IO management. So here we have to study disk structure and different disk scheduling algorithm. Disk structure and different disk scheduling algorithm, file concept, file access method, file structure, and at last different input output technique, that is programmed IO, interrupt IO, and DMA. So these are the syllabus which we have to study one by one in detail. So here we have total 5 modules. Module 1, this is on overview. Module 2, this is on process management. Module 3, this is on synchronization and deadlock. Module 4, this is actually main memory management. And module 5, this is actually secondary memory management and input output management. So these are the operating system syllabus. Okay. So now today I am going to start module 1, that is introduction. So in module 1, the first topic, this is introduction to operating system. Introduction to operating system. So here basically we have to study definition of OS, examples of OS, etc. So operating system is a system software. So very important point, it is a it is a system software. Operating system is a system software that acts as an intermediary between users and computer hardware. So it acts as intermediary between user and computer hardware and provides the user a simpler machine to work with. So in terms of user point of view, operating system is nothing but a basic platform by which user can interact with computer system or computer system hardware. But in terms of computer system itself, it is nothing but a resource manager. Resource manager. And that allocates and deallocates computer system resources in an efficient, fair, and secure manner. And we know that in our computer system, there are various resources like main memory, CPU, input-output device, etc. So operating system actually manages these various resources. That's why it is called resource manager. And operating system also provides a platform on which other application programs are installed. So basically we can define operating system in terms of user point of view, in terms of computer system itself, and in terms of application program. So in terms of user point of view, it is a basic platform. In terms of computer system, it is a resource manager, and in terms of application program, it provides a platform on which other application programs are installed. So these are the definition of OS and different important points on OS. Now, as for example, all you know Windows, Linux, Ubuntu, and for our mobile phone, Android. These are the examples of operating system which we are used in daily life. Now, actually, for better understanding these points, first we have to see the abstract view of computer system. So now see the abstract view of computer system. Abstract view of computer system. So here basically in zero level, this is computer hardware. Here we have different computer resources here, like CPU, main memory, IO, etc. So we can call it level 0. and it is very difficult to understand the language of hardware. And after that, we have another level. This is called operating system. And we can call it level 1. And after that, we have different system and application program. Here we have system and application program. And here we have, suppose, different application software, MS, Word, spreadsheet, suppose here we have web browser, and we can call it level 2. And at last we have user 1, we have user 2, and we have user n. So this is top level where we are existing. So this is the abstract view of computer, and in the core part we have hardware, and at the top level users are existing. And if we think, it is a very difficult task to communicate with hardware if there are no operating system. So if there are no operating system, then it is very difficult task to communicate with hardware, because the language of hardware is very difficult. So we have to manually tell the computer hardware each and everything that we have to do. So in the absence of operating system, we have to manually tell the computer hardware each and everything that we have to do. So in order to avoid this difficulty, we have operating system, and it resides between the computer hardware and the users, and acts as a basic platform between hardware and users. So actually operating system is nothing but the basic platform which creating an environment so that user can interact with computer hardware easily. Okay, so this is the all about operating system introduction. Okay, now next part, this is user operating system interface. User operating system interface. So in this part, there are basically two fundamental approaches for users to interface with the operating system. There are two fundamental approaches. So number one, this is called CLI, that is command line interface, or sometimes called command interpreter. So here, provide a command line interpreter or command line interface that allows users to directly enter commands that are to be performed by the OS. So in this case, we have to enter the command. And the second approach, this is called graphical user interface, GUI. So here just we have to click on the icon, and using this concept we can send the instruction to our operating system. So these are the user operating system interface. First one is command line interface and second one is graphical user interface. Okay. Now next, this is called operating system kernel. This part is very important. This is OS kernel. So actually kernel is a piece of code, and it is a place where a real work is done. So it is basically the core part or sometimes called monitor part of operating system. So if we see the basic structure, then in the core part in our computer system there exists hardware, and after that we have kernel, and next level we have operating system API or AUI. Actually API, the full form of API, application program interface, and AUI, that is application user interface. And the next part we have applications, and after that top level we have users. So basically kernel is the core part of operating system, and the interaction between hardware is done through this kernel. So this is the OS kernel. Now there are very important part after that. This is called system boot. So all of you must heard the word booting. People saying boot the computer, reboot the computer, etc. So what is actually booting? So actually it is the procedure of starting a computer by loading the kernel is known as booting. So booting is nothing but loading the kernel from secondary memory to main memory to start our computer system. So as you know operating system is the resource manager. So before starting the computer, we have to load operating system from secondary memory to main memory. And in case of booting, not entire operating system is loaded into main memory. Only the core part, which is called kernel, is loaded into main memory. So this is actually booting, loading of kernel from secondary memory to main memory is called booting. Now, how does this happen? So actually, you have the computer hardware, and also you have the OS installed and everything is ready. Now the kernel has to be loaded into memory, but the hardware itself does not know how to load the kernel, or how to locate the kernel and how to load it into the memory. So for loading purpose, we have something known as the bootstrap program or bootstrap loader. So on most computer systems, a small piece of code known as bootstrap program or bootstrap loader locates the kernel. So bootstrap program, which can help to load the kernel from secondary memory to main memory. So this program is in the form of read-only memory. So when the full bootstrap program has been loaded, it can traverse the file system to find the OS kernel, load it into memory, and start its execution. Then it is only at this point that the system is said to be running. So here the point is, it is the loading of kernel from secondary memory to main memory, and the program, this is called bootstrap program or bootstrap loader. This program is in the form of read-only memory. So this is all about system boot or system booting. Now the next topic which we have to study, this is called operating system services. Operating system services and operating system goals. So first, goals of operating system. So in this case, actually primary goal of operating system, this is convenience. Or user friendly. And the secondary goal of operating system, this is nothing but efficiency. So primary goal is user friendly and secondary goal is efficiency. So next lecture we have to discuss about operating system services. So I hope this part is very much clear to you. Thank you for watching and see you in the next one. Thank you once again.